Take a look at the question before you. This is the integral of dx over cosine of x, which might look a little bit ugly at first, so we can just rewrite this as 1 over cosine of x dx. And hopefully this is just something that you're more familiar with, but the format and everything should now be completely normal. The question is how we can actually find this antiderivative. And remember, there are no bounds, so we're not actually going to be evaluating it, we're just finding an expression. And so we're going to end off with some constant of integration called c, or anything else you want, but a constant of integration. So how can we do this? Well, let's start with something a little bit easier. We know the integral of cosine of x dx, right? And maybe we can get this in here somehow. This is pretty ugly, but this is pretty simple. This is just going to be sine of x plus c. Well, what is 1? Obviously, it's a lot of different things, right? But one way we can write 1 in terms of the trigonometric functions is as cosine squared x plus sine squared x. And the reason I'm doing this is because we're going to divide it like this by cosine of x. This is the exact same thing, right? And now we can actually break this up a little bit more. So this will just become cosine squared x over cosine of x plus sine squared x also over cosine of x. And then we have the dx. So this is just the basic addition property, I guess, right? You can write the sum of an integral as the integral of the sums, or whatever, however you want to say it, right? And so regardless of that, this is now just the integral of cosine of x plus sine squared x over cosine of x. And it might look like we've actually made our job a lot harder over here. And yeah, you're not wrong for thinking that. We've got two terms now. We've got a sine square in here, but this is actually easy, right? Because we know what the integral of cosine of x is, so we can, just to be very rigorous, I'll write it like this. We're now breaking it up into two separate integrals. Okay, yeah, so now here's where we are. What do we do now? Well, what's the integral of cosine of x dx? That's just sine of x plus c. I'll call that c1. And now we have this. This seems a little bit harder. And there are a few different ways you can go about doing it. One way you shouldn't do it, like just in case you're thinking about it, like maybe you can write this as 1 minus cosine square x over cosine of x. Don't do this, because think about it. This is just undoing what you just did, right? And so you'll end up getting minus this, and then you'll have 1 over cosine of x. So that takes you nowhere. So don't do anything like that. Instead, what can we do over here? Well, it is a little bit difficult, right? Maybe you want to do something like u substitution. The only issue is that the cosine of x is now in the denominator, right? If we had cosine of x over sine squared x, that would be easy to do, right? We know how to do this. This is just negative 1 over sine x, I think, something like that, right? It's not so easy though. So we need to find something else. And there are a few different ways of going about doing it. Actually, I'm not too sure what to do here, funnily enough, but yeah, maybe we can multiply by cosine of x, numerator and denominator, right? And now, alternatively, okay, so let's see. Perhaps we can do something like this, right? So we'll have, it is 1 minus cosine squared x, but we'll write this as 1 plus cosine of x times 1 minus cosine of x over cosine of x. And now this should hopefully be a little bit easier for us. Or is it? No, this is going to be the same thing again. Okay, so it's a little bit ugly, but just see if you can do some u substitutions or whatever to simplify this. I don't immediately see what it could be. Oh, one sec. This is just tan x secant of x, right? Tan x, okay, secant of x. If you rewrite it like that, it might become a little bit easier. But is that correct? Well, yeah, right? It's sine of x over, oh, sorry, no, it's tan x times sine x. Oops. All right, yeah, it's a little bit ugly still. Let's go back to that older idea that we had with cosine x sine squared x over cosine squared x. And maybe we can now consider rewriting this instead. Yeah, okay, now this should work. It's just a little ugly though. So we have cosine x times sine squared x over 1 minus sine squared x, right? And now we just do the u substitution um uh with okay, well first we can simplify this a little bit, right? We can do cosine x times sine squared x minus 1 plus 1. All right, and so hopefully you get the same thing. Hopefully I'm not messing it up over here, but it should look something like this, right? I think that's correct. And so, and remember, we're still integrating all of this. So now we have the integral of, okay, negative cosine of x dx plus cosine of x over 1 minus sine squared x dx. All right, so we're getting a little bit closer now, right? Remember that we had initially just the integral of cosine of x dx, and then there's some constants here and there, but the constants will always exist, so we can cancel this out with the initial cosine x dx. So now it's this that we have. Okay, this is all we have to worry about now. And so, oh goodness, yeah, there was a much faster way of doing this, I think, now that I look at it. So we could have just multiplied by cosine of x. Well, yeah, this is what happens sometimes. Sometimes you could have just multiplied by cosine x over cosine x and you would have gotten the exact same thing that we have here. So yeah, I mean we wasted a lot of time, I guess, but at least we got there in the end. And I'm very rusty. Like I haven't touched integrals in quite a while. I just thought these might be interesting. So sorry about that. If you got here right off the bat and you thought that you were wrong because I showed you all that other stuff, just lesson is to have more confidence in yourself because clearly I screwed up there. But yeah, now the question is how do we actually do this? It's probably not that hard, right? I think we can say um, we can so this is 1 minus sine x times 1 plus sine x, right? And so this is 2 minus sine x minus 1. No, plus 1 times sine x plus 1. In the denominator and above it we have, okay, so I'll just write it out properly. So it's something like this now. Very, very ugly work here. Yeah, I mean, hopefully, I'm sure you're better than me at doing this. So maybe just fast forward to the end and see the final answer. But yeah, this is what we want. Now we can let u equal sine x plus 1, which means that du is equal to cosine x dx. And so now we're left with, at long last, cosine x, sorry, du over 2 minus u times u. Great, and this might look, again, this is worse than what we had in the beginning, possibly, but I think we're close to the home stretch now. So we can write this as negative the integral of u times u minus 2, u squared minus 2u, and I mean, you'd like to complete the square now, right? So you do plus 1 minus 1. Now what do you have? Now you have, God, I've done this badly. This is very, very ugly. You know what? Okay, maybe this is like the bad way of doing it. And now once you've seen this, you'll know not to repeat it. So there's something to take away regardless. But anyway, this is now u minus 1 whole squared minus 1. Is that correct? Plus 1 minus 1, yep. And then this is du. And then we're doing this integral. I don't even know what to do here, to be honest. I think, okay, wait. Isn't this just, isn't it 1 plus x squared in the denominator? Hmm. Yeah, I mean, maybe mess it up even more now. What have I done? I guess okay, fine. So it's basically the integral now of du over 1 minus u minus 1 squared. Oh, so there's no need to do all this. We can go from here until here. I'm sorry, I'm very rusty. I should. So this is just a little bit of what's it called? Like partial fraction decomposition. So it's something like this, right? And what is this going to give us? This should end up giving us -1 on the top, right? So we want, so a equals -b, and then -2a equals -1, which means a equals 1/2 and b equals -1/2. So now let's plonk these into our equation. We have 1 over 1/2, 1 over 2u minus 1 over 2u minus 2 equals whatever, right? Equals the integral of this du. This is going to be 1/2 times the integral of 1 over u minus 1 over u minus 2 du, right? And that seems about right to me as well. Yep. And now this will just be natural log of u. Well, okay, natural log of u minus natural log of u minus 2, 1/2 over here, plus c. So I'll put in the plus c at the end. It'll be like this, u over u minus 2 plus c. Now remember, the way I've done this so badly, you shouldn't even have the u, right? U is equal to sine x plus 1. So now this just becomes 1/2 natural log of sine x plus 1 over sine x minus 1. And something tells me that there are plenty of ways to simplify this more, and this is definitely not how it should look. So let's try that then, right? Yeah, I mean there's, oh, okay. So yeah, I mean very ugly here, but let's try it anyway. This will just be 1 plus sine x squared over cosine squared x. And then there's a 1/2, so that means nicely enough that goes in here. And so now we just have the natural log of 1 plus sine x over cosine of x plus c. So this might be, some sort of world record for the worst possible way to go about doing a question and still getting the right answer. So that's why I'm probably going to still put it up on YouTube. But besides that, really a terrible video. Hope I'm sorry you have to see this. But if you have seen it, my other videos, I think every one of them is probably better than this. So please consider subscribing just for that. And yeah, I'm so surprised by this, that I'm gonna have to verify my answer once. So let me just check the integral of secant of x. I think that's what we did. I'm not sure at all if this is correct. Oh, okay, it's let's see. I just want the answer. They're showing me some weird stuff. Okay, it's like tan of theta plus secant of theta. That's the same thing though, right? Okay, yeah. So we can rewrite this a little bit more, and I might as well now because this is definitely the neater part of our work today. This is 1 over cosine x plus sine x over cosine x, right? And so you can also rewrite this as just secant x plus tan x and then plus c. All right, and now we're done. Horrendous work. I think it is a pretty easy one usually, so it shouldn't be this difficult to solve it, but for me it was for whatever reason, so I'm so sorry for this, but yeah, thanks for watching, thanks for bearing with me, and I'll see you in the next video. Bye bye.